documentation, and since this is about documentation, let's first start by looking at some code. All right, so that is way too small for the people in the back, I imagine. You guys can, okay. Well, suffice to say this isn't important, but I'll walk through it here. So, like, what does this code do? Just by looking at it, I can't really tell you. It looks like we have some kind of floating point number here. We're gonna cast all of its bits into a long integer. And we're gonna bit shift it, and then we're gonna, why? I don't know what that number is. Why is that doing that? Okay. And we're gonna cast it back and do a whole bunch of other math on it. All right, so, well, I've read it and I still don't know what it does. So let's back up a bit. Okay. Okay, so this is called reciprocal square root. Okay, so this is giving me the reciprocal square root of a number. And this is actually a really, really important function for video games. However, if I were in my professional development to ever see code like this, one of two things would happen. First, I would look at it and I would say, okay, well, this is too complex to understand, so it must be very, very important, and I will never touch it. But now that I've been doing this for a little while, I've decided now that it's too complex to understand, so it must be deleted. And replaced with this. So every single language out there under the sun has a math library. In that math library, there will be a square root function, and the reciprocal square root is just 1 divided by the square root of the number. So, so if every language has this, why would I have this big, huge, complicated mess? And the answer to that is actually pretty fascinating. It turns out that this bit shifting hack and this magic number actually calculates the reciprocal of the square root really, really fast, because division is very slow and square roots is even slower. In fact, our best way of calculating square roots is actually to guess and then run it through this line here, which is called Newton's algorithm, which makes a better guess. And then if you keep running that over and over and over again, you get a better and better guess until eventually you get something close enough that you don't really care anymore. This code was made famous by Quake 3 Arena, though it existed probably for 20 years before that, so this is from the 70s. But now that I've replaced that old ugly code with this new clean code, I've broken my game. My game will not run anymore because this is really, really slow. So there must be a way to prevent me from going in and changing all this code. And earlier, the git commit message presentation, that's actually a hugely useful way to do this. In fact, I do consider git commit messages to be a form of documentation. But rather than that, we could just write the documentation in there with the code. So here is an example of some documentation that I would have written when I first accepted the fact that documentation is necessary. We've got a sentence here that describes what the function's about to do. Explanation here of the input. We've got an input named number, and it's the input number. That's useful. And then we've got a return value, which is the reciprocal of the square root of the input. That's also very useful. So yeah, what does this documentation actually provide us for value? The function name already tells me what it does, so I don't really need to say that. I've already declared that the float number is a number, so I don't really need to say that. And it seems redundant to say that the reciprocal square root function returns the reciprocal square root of a number. So this is what people will call self-documenting code. And it is extremely useful. It goes a long way to making your code more readable and easier to use. So much so that some have actually advised against documentation entirely. And if all your documentation is just like this, well, I don't really blame them. But to me, this is not very good documentation. Good documentation will start out first with what does the function do. It will also, yes, describe what are the inputs, but most importantly, it will describe why this function exists. And even more importantly, how do I use it? So questions 1 and 2 you can answer yourself by just reading this code. But questions 3 and 4 are really only answerable by some kind of prose next to or around this function. So here's an example of some good documentation. I describe here what the function does. It quickly calculates the reciprocal of the square root of the given number. And then I explain why I'm using this method as opposed to any other method. If I use this, other than the standard square root function, I use this for performance. The next thing I do is I link this to the greater project. So I've got another class called vector2, and I say that, okay, well, this is actually used under the hood by the vector2 class to calculate, what is it? Vector magnitudes and the unit vector. These are for other calculations for like where light bounces off of objects, that kind of thing. Then I have some example code. So this is, in theory, code that you might yourself write or see around the code base. And then, since I'm really feeling helpful, I'll actually give a Wikipedia link to the document, to the Wikipedia article about describing this algorithm. There's actually some wonderful history there about like where people found this out and actually even how that magic number that was derived. Links are very, very good. You should use them a lot in your documentation, either links to Wikipedia or even just internal links. All of the documentation engines usually have a way to do internal linking. So really great documentation. So that was just kind of basically my minimum now acceptable level of documentation. To go the extra mile, basically before I release software, I will go an extra mile and I'll say, you know, more than what, or even more than how, but again, why this project exists, why this code exists, why this function exists, and why it's useful. Really great documentation, teaches the concepts around this code, teaches the business rules that this code implements, and even indeed will teach the domain model that this software was built for. As all of this is kind of necessary to understand the code that you're working with. And even truly great documentation will explain when to use something else. So if my project is not quite the perfect solution for you, here are these other projects that maybe actually do it better for you. For me, especially, documentation remembers, so I don't have to. Indeed, that's a lot of what we do here. Is we're building these huge systems, and then we have to remember and maintain them. And a lot of, like Andy was saying, a lot of what's lost in college teaching is that we're always going to come into a software project in progress, and we have to be able to pick it up, work on it, and then put it away and come back to it again later. So to write good documentation, make sure all of your modules, classes, libraries, collections, or otherwise have clear descriptions, numerous examples, plenty of internal and external links for cross-referencing, and repeat the same thing indeed for every function, method, subroutine, or other piece of runnable code. Give them a description, give them some examples, and give them some links. Documentation answers the why of all of this code. And remember that software is indeed more than just the code that we write. Thank you.
Do you have any good examples of open source projects that have A+ documentation?
So most of the languages that I've learned, Python especially has really, really good documentation. I was actually Ruby on Rails. I was working with that last month, and their documentation is really good. I am out of time, so I'm not going to demonstrate my own bad and good documentation, but I've also, MySQL, the MySQL documentation is actually, I spend a lot of time these days in there, and I'm generally okay with it, but after 20 years, documentation does accumulate its own amount of bit rot, so it's interesting, but yeah, definitely Python I would probably hold up as a paragon of good documentation. There's always examples, there's always explanations. You can basically copy and paste runnable code. from that. So.
Awesome. Thanks, Doug.
Thank you.